Welcome. This is going to be covering the practice problems for 5-4 solving compound inequalities. In this video, I will be covering the problems in checking your understanding, which is 1 through 5, as well as the practice and problem solving, number 7, 9, and 12, as well as 18, 19, 20, and 21. So please take this opportunity now to pause the video and attempt to do the problems before I go over it. Again, it is 1 through 5 for check your understanding, and 7, 9, 12, 18 through 21 in the practice and problem solving. Alright, this is number 1 in checking your understanding. We have these two inequalities and they make a compound inequality because of the word and. Okay, they intersect. Note that you cannot put this into compact form because, do you see, this is p minus 8 and this is p minus 14. You can't put it into one form. Okay, so what we have to do is treat it as two inequalities. Solve the left inequality as step 1. So I'm going to write my original inequality. 4 is less than or equal to p minus 8. I'm trying to get p alone, so I'm going to add 8 to both sides. Then I get 12. 4 plus 8 is 12, is less than or equal to p. That is what I get after I simplified. Step 2, I'm going to solve the right hand inequality now. P minus 13 is less than 2. Add 13 to both sides. Then you get p is less than or equal to 15. Combining the two solutions, okay, I get the solution set of p. P is greater than 12, is greater than or equal to 12, but less than or equal to 15. Because again, I am combining this solution with this solution to get the solution set. And if you graph it, it exists like this. P is a value that exists greater than or equal to 12, that's why it's closed, but less than or equal to 15. 2. R plus 6 is less than negative 8, or R minus 3 is greater than negative 10. These two inequalities is a compound inequality with a union because of the word or. First step is to solve the left inequality. R plus 6 is less than negative 8. That is my original left inequality. Subtract 6 to both sides because I'm trying to get R alone. You get R left over on the left hand side, which is less than negative 8 plus negative 6 is negative 14. So R is less than negative 14. Step 2, solve the right inequality. R minus 3 is greater than negative 10. That is my original right inequality. I'm going to add 3 to both sides. You get R is greater than negative 7 because negative 10 plus 3 is negative 7. R is greater than negative 7. This is the solution set, R. So your two solutions, the left hand inside inequality solution and the right hand side inequality. So your solution set is R is less than negative 14 or R is greater than negative 7. Remember, this is a compound inequality with the word or. So if you graph it, you have R is greater than negative 7. It's open here on negative 7. It goes all the way to the right. And R is less than negative 14, which is open here on negative 14, and it goes all the way to the left. Number 3, 4a plus 7 is greater than or equal to 31, or a is greater than 5. This is a compound inequality with that is a union because of the word or. Step 1, you want to solve the left inequality. 4a plus 7 is greater than or equal to 31. Subtract 7 to both sides. Then you get what's left over is a 4a on the left hand side, a 24 left over on the right hand side because 31 minus 7 is 24. Divide 4 to both sides because you're trying to get a alone. A is greater than 6. 24 divided by 4 is 6. So A is greater than 6. That is your left hand side of the inequality solution. Solving the right hand, side of the inequality, a is already greater than 5. Notice that the right hand side inequality is already solved for. So you can put this into your solution set. It's a solution set of a is greater than or equal to 6, or a is greater than 5. You notice how I graphed it? It's open here on 5, but it goes all the way to the right. It's closed here on 6, and it goes all the way to the right. So we say that this a is greater than 5 is a subset of a is greater than 6. Okay? Oh, this is off. 5 should be here, 6 should be on the right. Okay? Because anything greater than 5 is also greater than 6. Right? So these is actually flipped. The next problem, you have, okay, 2 minus 2 is less than or equal to g plus 4 is less than 7. This inequality is already in compact form, so that is really good. We're going to subtract 4 to both sides. You get, this is off, right? Oh, no, this isn't off. 2 plus negative 4 is negative 2. That's correct, right? Plus 4 minus 4, that becomes your 0. 7 minus 4 is your 3. That is correct, okay? Notice how, everything comes straight down. Let's simplify this because we really don't write this plus 0. So it becomes negative 2 is less than or equal 2 is less than or equal to g, which is less than 3. That's what it looks like. This is an intersection. Your solution set is g, and g exists less than 3 but greater than or equal to negative 2. This is how it looks like. It's open here on 3. It goes to the left because it's less than. And it's greater than negative 2, which is closed on 2, and it goes all the way to the right. Number 5, you have this word problem. The recommended air pressure for the tire of a mountain bike is at least 35 pounds per square inch. It's called PSI for short, but no more than 80 pounds per square inch. If a bike tire has 24 pounds per square inch PSIs, if a bike tire already has 24 PSIs, what is the recommended range of air that should be put into the tires? The reason why it needs more than 35 at least is because for it to get traction. But if it has more than 80 pounds, 80 PSIs in your tire, you're going to actually blow up the tire. So, when you get a big word problem like that, it is very scary. So, extract piece by piece, one step at a time. So just look at the important information. The recommended air pressure for the tire of a mountain bike is at least 35 PSIs. That looks like that is very important. So I highlighted that. Okay, is at least 35 PSIs. Then it says, but no more than 80 PSIs. That sounds also important. No more than 80 PSIs. Then it says if a tire has already 24 pounds or 24 PSIs, that's also important. The tire already has 24 PSIs. And it says, what is the recommended range? It is very crucial for you to isolate this last part because that last part is telling you what the question is asking you to find. In a word problem, you have to make sure you're answering what they're asking you for. So, step 1 is always to label your information. We highlight it here or extract it, so labeling your step should be very easy. Let x be the tire pressure because we always have to define our variable first. And it says least 35 pounds, that is x is going to be less than 30, has to be greater than or equal to 35. It says at least, so it can be the value of 35. But it says no more than 80 means that x has to exist below or equal to 80 psis. Then if it says if a bike tire already has 25 pounds per square inch, it means x is already plus 24 because it already has 24 pounds there, psis in their tire. So when it's asking you for what is the recommended range, it's asking you for what is the solution set, because the solution set gives you a list, right? A range of solutions. So it's very important to, again, label your information, okay? This comes from the previous slides. Because from this information, we could actually do the work. We can put this into, because x plus 24 has to exist right here. less than 80, but less than or equal to 80, but greater than or equal to 35. Then you want to solve for x. So you subtract 24 to both sides. Then you get 35 minus 24, which is 11. On the right hand side, 80 minus 24 is 56. Okay? Then you want to simplify. X is greater than or equal to 11, but less than 56. What this means in the context of the problem is, if you already have 24 psi's in your mountain bike, okay, you only want to increase it by either 11 is the smallest that you should have it, or 56 is your largest that you should increase it by. If you go more than 56, your tire is going to blow up because it's going to break that maximum 80 psi's. So your solution set is x. X is less than or equal to 56, but greater than or equal to 11. Let's do number 7. Remember, these problems are in the practice section. 7 says n plus 2 is less than negative 5, and n plus 6 is greater than or equal to negative 6. Note that you cannot put this into compact form, so you just have to treat this as two separate problems. So solve the left inequality first. N plus 2 is less than negative 5. Subtract 2 to both sides. You get n is less than negative 7. N is less than or equal to negative 7. Negative 5 plus negative 2 is negative 7. So you want to solve the right-hand side of the inequality now. N plus 6 is greater than negative 6. Subtract 6 to both sides. Then you got n is greater than negative 12. The solution set is n. N is less than or equal to negative 7, but greater than or equal to negative 12. If you graph it, it looks exactly like this. It's closed 0 on negative 7, and n is less than, so you go to the left. But it says n is greater than negative 12. You go to negative 12, close that because it's equal to, and you go all the way to the right as well. Okay? 9. T plus 14 is greater than 15, or t minus 9 is less than negative 10. Solve the left inequality first. T plus 14 is greater than 15 is the original left inequality. Subtract 14 to both sides. Then you get t is greater than or equal to 1 after you simplified. Then step 2, solve the right inequality. T minus 9 is less than negative 10. That is your original right inequality. Plus 9 to both sides. Then you get t is less than negative 1 after you simplified. Your solution set is t. T is less than negative 1, or t is greater than or equal to 1. Right? Again, you're combining the two solutions, the left side of the inequality and the right hand side of the inequality. If you put this in your graph, it says t is less than negative 1. T, right here, is less than negative 1, so it's open here on negative 1 and goes all to the left because those are the values that t is less than negative 1. T is greater than 1. T is greater than or equal to 1. It's closed here on 1 and it goes all to the right because these are the values that t is greater than or equal to 1. So 2, 3, 4, 5 works. Number 12, 5h minus 4 is greater than 6, and 7h plus 11 is less than 32. Again, you cannot put this into compact form. So you have to solve this left inequality. 5h minus 4 is greater than 6 is the original left inequality. Plus 4 to both sides. You get 5h is greater than or equal to 10. Divide by 5 to both sides because you're trying to get h alone. H is greater than or equal to 2 after you simplified. Step 2, solve the right inequality. 7h plus 11 is less than 32. Subtract 11 to both sides. You get 7h is less than 21. Divide 7 to both sides because you're trying to get h alone. H is less than 3. Your solution set is h, and h has to exist less than 3 but greater than or equal to 2. So if you graph it, h has to be less than 3. It's open on 3 and goes to the left, but h has to be greater than 2. So values exist here like 2.1, 2.4, 2.5, 2.6, 2.8, right? Any value that is in between here would make this inequality valid. Number 18, 18, 19, 20, and 21, they already give us the graph, and we have to write the inequality. Again, you have to look if it's a union or an intersection. Review that video if you need further explanation on the difference between the union and the intersection. This looks like it's an intersection because it's a combination of two inequalities. The first one, it looks like x is greater than -1 because, again, how I get the greater than or equal to symbol is it's closed here on -1 and it's going all the way to the right. Do you see how the arrow here points all the way to the right? Do you see how the arrow here points all the way to the right? Good. And it looks like it's also closed on 4, so x is less than 4, less than or equal to 4, because it's going all the way to the left. Do you see that? Right? So x is less than or equal to 4. Put this into your solution set format. You say x exists less than or equal to 4 and also greater than or equal to -1. 19, it's open here on -3 and it's going to the right. So we say x is greater than -3. And because you see it's an intersection, it's here, which is 2. X is 2. What is that? It's going to the left, so x is less than 2. Less than or equal to. Less than or equal to 2 because it is closed here. Okay? Your solution set is x. X exists less than or equal to 2, but greater than -3. 20. This looks like it's a union now because these are two separate inequalities. The first one is x is greater than or equal to 3. It's closed there on 3 and it's going to the right. Or, because again this is a union, x is less than 0 because it's open here on 0 and it's going to the left. Your solution set is x is greater than 3, or x is less than 0. 21. Again, this looks like a union because they show two different circles and it's going to their own direction. The first one is x is greater than -3 because, again, it's open here on -3 and it's going to the right. Or, because this is a union, x is open here on -4 and it is less than. So x is less than -4. Put this in your solution set format. We say x